Hey, hello geometry friends. We are nearing the end of our first week, and so this video is our first review video. After so many sections, we have these sections called Ready to Go On, abbreviated, as you can see, RTGO. And so we are reviewing sections 1.1 through 1.4, and then that'll be our quiz on this Friday. We'll be on those sections 1.1 through 1.4. So this is kind of a nice stop to pause. No new material today, but just to go back and practice the different sections that we've covered so far, and maybe how you can identify where you need a little more work or if you have some specific questions. Because maybe you understood some of it, but there's certain sections or types of problems that you struggle with. This is a good time to focus in on those in preparation for our quiz this Friday, kind of the halfway point through chapter 1. Okay, so you could see this is on page 35, 1 through 11, 14, 15 through 25, odd. Now, obviously 14 is not odd, but everything else is odd other than problem 14, but I wanted to make sure you were assigned that. Also, something to note about these reviews is that the answers I don't believe are in the back of your textbook. And so what you'll find whenever you have this assignment is I have attached a PDF of my teacher's guide, my teacher's edition, that has the solutions there. So in order to check your answers, you're going to need to look at that PDF for each of the problems. I'll go ahead and just be solving. I think we're doing 5 of these right now. 2 of them will go real quick. Okay, so let's jump right in and start our review of sections 1.1 through 1.4. The first one I wanted to work through, I pretty much picked kind of the algebra-based ones to walk you through. And so obviously you have questions on the more conceptual ones. Let's use our live class on Thursday or in any time Zoom chat before the quiz. You can ask me for help on any of those. But number 14 is, again, part of 1.2 where we were measuring segments. And that was where we were dealing with midpoints and using expressions to solve for the lengths of segments. And so we have number 14 reads, Q is the midpoint of PR. Okay, so let's go ahead and draw our line. Get my pencil. Draw our line P R. Let me get this right, PR. And then it says Q is the midpoint. So we'll put our midpoint right there. Okay, it means it's right in the middle. I'm going to make a mark here because midpoint means that these two pieces are equal in length or congruent. So that's important to know. Then it gives me an expression for PQ. It says PQ is 2z. So that's this half here on the left. So that's 2z. And then it says PR is 8z minus 12. If you notice, PR is the entire length. It's not QR. So be careful. Again, label slowly and make sure you read carefully what you're supposed to be labeling. But that's 8z minus 12. And then the instructions are to actually have 3 answers. Find z, PQ, and PR. So first we're going to find the variable. Then we're going to plug that variable in, and we can solve for this half segment and then the whole segment. Notice I've already kind of made a mistake. It is z, not x, because if the variables were different, that would be an issue. But no, it's 8z minus 12. Okay, so we have expressions. We need to be able to write an equation. What here is equal to what? Don't say that 2z is equal to 8z minus 12 because you're basically would be saying that half of the segment is equal to the whole segment. So always, this is the most critically thinking part after you've carefully labeled your answer. But again, the key is the midpoint, that 2z is half of PR. So in other words, if I were to double 2z, if you were to think, oh, there's 2z and another 2z here, now that's the entire line. So it's not 2z, but 4z is equal to the entire line. So 4z is equal to all of PR, or the 8, oops, I'm using x again, just a habit, 8z minus 12. So there's our key equation that's going to allow us to solve this. Again, we just had to double PQ because it was half of the entire line. Now we go into algebra mode. I'm going to put my z's together. I want to subtract the smaller from the larger. So 4z on both sides minus 4z. Okay, that cancels out. And so we are left with then, let's go and do this. 0 equals 4z minus 12. Now we got to get z by itself. So now we're going to go ahead and add the 12 to both sides because that's the opposite of subtracting 12. So plus 12. That's going to cancel out there. And so we now have 12 equals 4z. Opposite of multiplying by 4 is dividing by 4. So we're going to divide by 4. Cancels out. And we get finally our z answer. Z is equal to 3. Alrighty, and that is actually one of our final answers, so I'm going to box it. We needed to find z, and so z is equal to 3. And now we're going to use that to find, it says we need to find both PQ and PR. So that means we're going to plug it into two places, PQ and also my PR. So I can just do that pretty quickly. 3 times 2, because PQ is 2z, so 3 times 2 is 6. So that means that PQ is equal to 6. And PR is twice as big. I could plug it into the 8. You could go 3 times 8 is 24. 24 minus 12 is 12. Or I could just go, well, if half of it's 6, then the entire thing, PR, must also be 12. Which is nice. I can check and see that I've done this right. So the entire segment, PR, is equal to 12. And I can box those because those are also final answers. Okay, so there's your typical solving for segments problem using midpoint, which again is important because it divides a segment into 2 equal halves, which is then your clue to setting up the right equation. Okay, let's move on to, we're going to do number 19. Number 19. Similar problem, only now we're using bisectors, and we're in 1.3 is very similar to 1.2 in terms of the type of algebra you do, but now we're talking about angles. But it's kind of a lot of the same concepts, because number 19 reads that ray RS bisects angle QRT. Okay, so we've got an angle, and this is angle QRT, and now we have ray, ray RS. So we've got some sort of a ray coming out, and we call that RS. Now it does not only, it says it bisects. So again, that's a key piece of vocabulary. That means it's cutting this larger angle into 2 equal halves. So I know that QRS is equal to SRT. Okay. So then they give me some measurements or expressions. It says that QRS is 3x plus 8. QRS. Remember, it's always important to identify which angle you're talking about. So it's that top one. That is 3x plus 8. And then it says that SRT, again, SRT, so it's that bottom angle, is 9x minus 4. And so we need to find SRT. So I'm actually going to be finding not x, not the whole angle, but I'm going to be finding SRT here at the bottom. Okay, so equation time. Okay, the key skill. How do these two things relate? Well, they're both equal halves of a bisected angle, so it's a fairly straightforward equation. It's just going to be, they're equal to each other. 3x plus 8 equals 9x minus 4. And then we can go into algebra mode. All right, since we got the smaller 3x over here, we're going to subtract 3x, do it from both sides. That's going to cancel out. And so we now have 8, positive 8, equals 6x minus 4. We can move that negative 4 by doing the opposite operation of adding 4 to both sides, canceling out on the right. So now we have 12 equals 6x. And we're going to divide by 6. It's the opposite of multiplying by 6. Hopefully you're doing enough of these. Again, they're getting in those reps that solving these equations are just, you can go a lot faster than maybe I'm going right now. So 6x cancels out, and 12 divided by 6 is 2. So we have our value for x. 2 equals x, or x equals 2. That's not our final answer in this case. Always check, especially when you take the quiz on quizzes and you're just pushing answers. You want to be careful, because I can guarantee you if this was a multiple choice question, one of the answers would be 2. And if the question's asking you not for x, but it's asking you for angle SRT, you'll do almost everything right. You'll hit 2, and then you'll miss it because you didn't read the question carefully. So we actually need to plug this into our SRT, because here's SRT. So that's just 9 times 2 minus 4. 18 minus 4, 14. And this is an angle, so let's not leave it naked. Let's give it some units. 14 degrees. Bama shama, ding dong. There we go. 14 degrees. Check my answer, and that is correct. Okay, so similar to number 14, ones where we had a section on segments, and section 1.3 is on angles, but a lot of the same procedures. So let's go ahead and look at two more I wanted to cover just because they were more vocabulary based and they won't take us long to talk about. So 21, and actually we can do them pretty much together, 23. And they're both based upon this drawing. Let me sketch it really quick. Not doing too sloppy of a job. Then we've got angles 1, 2, 3, 4, and 5. Okay, and in this problem, it's asking, tell whether the angles are only adjacent and form a linear pair, or not adjacent at all. So again, vocab, adjacent means you're next to. So for two angles to be adjacent, they have to have a common vertex and a common side. They're just two angles that are right next to each other. For them to form a linear pair, they basically have to form a line. Again, and that word linear is the word line. So together, the two angles are not only next to each other, I don't know how to show that, but next to each other, but together they form a straight line, or a linear pair. Or they're just not even next to each other at all, and we'll note that. So 21 asks for angles 1 and angle 2. Okay, so first thing we can see is if we look, they are definitely adjacent because they are right next to each other. They share this ray right here. Okay, so that means that angles 1 and 2 are definitely adjacent, and I'm just going to abbreviate that, ADJ. Now, do they form a linear pair? Well, you can see, yes, together here, and then here you've got the straight 180-degree line going up and down. So together they do form a line. So yes, they are a linear pair as well. So just a chance to review with you what those two things mean. Okay, 23 asks about angles 3 and 4. Okay, are they adjacent or a linear pair or not adjacent? Well, you can see they do not share anything in common except for the vertex. They do have a common vertex, but that's not enough. They're not next to each other. And so this is a simple one. They are non-adjacent. Okay, I could box these answers. Sorry, a little sloppy there. Non-adjacent. So just making sure we can understand what that vocabulary is. I will also note that just other vocab review in terms of vertical angles. The angles that are vertical here are angles that are formed by two lines crisscrossing. Okay, 3 and 4, you can see they're not formed by the same two lines that are crisscrossing. So you wouldn't call 3 and 4 vertical. But if you look at, you've got this line and this line, they do form a set of opposite angles. So 1 and 4, this is not being asked, but just can't help pointing it out because I want you to do well on Friday and beyond. 1 and 4 are vertical angles because that was another type of angle we talked about. The other thing you'll see is you'll need to be able to tell whether things are straight angles. Angles 1 and 2 form a straight angle because that equals 180 degrees, or acute, less than 90 degrees, or obtuse, greater than 90 degrees. All right, last one I'm going to do with you from the ready to go on, and that is number 25, because again, I think this is kind of just a tricky but very doable type of question. And that is when they ask you to express supplements and complements in terms of x, basically, in terms of not knowing a certain degree. And so it says the measurement of angle T is 5x minus 10. Find the measure of each of the following. So if T is 5x minus 10, and then 25 says find the complement of angle T. So in other words, if the complement, the key is to remember that complements add up to 90 degrees. So if we're here, we've got a 90-degree complement, and one of these angles, we could call this angle T. And I don't have to draw this. I'm just going into way over detail to try to make it clear. Measurement of angle T is 5x minus 10. So how would I express the complement of t? Well, as we discussed in this lesson, this is from 1.4, complements, it's always, well, you have the entire set, which is, because it's a complement, that would be 90 degrees, this entire 90 degrees. And if I then subtract t from that, then I'll have this one that's missing up here. This is the complement. The one on the top is the complement of t. So we simply just go with the total, 90, minus then 5x minus 10. And that would be this leftover region. Whatever we get from subtracting, that's this angle that we don't know right here. Okay, so 5x minus 10. And again, notice the parentheses. When you're subtracting an expression, you got to put the expression in parentheses because that's going to change the signs. Subtracting 5x is going to be, I'm subtracting the 5x, but then I'm also subtracting the negative 10, so it's actually like I'm adding 10. So in order to fully get this right and simplify it, I have to go, okay, so that's 90 plus 10 is 100 minus 5x. Okay, and so this top angle, the one I put the question mark on, that would be 100 minus 5x. And we could say degrees if we want, because it is an angle. So again, probably not, we'd always like to just get a number answer. Oh, it's 30 degrees. Well, we're doing that, but we're doing it with an expression. If I knew that this t was 40 degrees and I knew it was a complement, well, I would just do 90 minus 40 and I'd know, okay, the complement is 50 degrees. Sometimes, again, they'll give you an expression and you just do the same thing, but you have to leave it as an expression. With, again, this tricky little step of including the parentheses so that the negative gets distributed to everything within that expression. Obviously, quick extension, if this was the supplement of t, the process would be exactly the same, except instead of 90, you would do the whole thing as 180 minus the 5x minus 10. Okay, so that's key. Make sure you know the difference between complements and supplements. Alrighty, that's the few sample problems I'm going to do from the Ready to Go on, but now is a very key time to ask for help. And if you don't understand one of the sections, get that, because the quiz is coming, and then shortly after, we'll be doing the full chapter test, and we'll be learning new stuff next week. So really key to success in this class is building each step successively and getting help in the moment. Don't procrastinate, or it really starts to snowball. All right, good luck. See you guys on Thursday and then Friday as well.